Hello everybody. For this video assignment, you're going to write what I write and draw what I draw. It's going to be a notebook page, and the notebook page is going to be called Relative Dating Rules. So relative dating means you're looking at a segment of rock layers and trying to determine which ones are older and which ones are younger. So I'm going to draw my surface here with a paleontologist who studies geologic time, standing on the surface with a shovel, getting ready to dig. And beneath my paleontologist are some horizontal layers. Now, the law of original horizontality states that sedimentary rocks form distinct layers. And you could, put some dots on every other one just for fun to show that they are distinct layers of sedimentary rock. And the law of superposition states that the oldest rocks are on the bottom and the youngest rocks are on top. So if this was layer A, B, C, D, E, you could say with some confidence that A is older than B, and B is older than C, and C is older than D, and D is older than E. That's how the law of superposition works. And something else that plays into that is the law of original horizontality, which says that sedimentary rocks form in distinct layers. But we won't write that down this time. The second relative dating rule that I want you to be considering is something called the law of cross-cutting. So in this situation, you have perhaps a fault and some layers of sedimentary rock. Like, let's say this is layer A, this is layer B, this is layer C, this is layer D, this is layer E. And then this is also layer A, this is layer B, this is layer C. And then maybe on the picture, layers D and E are cut off. But you can say with some certainty that movement has occurred along this fault, and A used to be lined up with A, and B used to be lined up with B, and C used to be lined up with C before the fault occurred. What the law of cross-cutting says is that the fault or intrusion is younger than the layers it cuts across. And so the fault itself could be a layer. We could call that layer X. And X is younger than A, B, C, D, and E because it cuts across all of them. And in the same picture, you could also have an intrusion. And if there's an igneous intrusion, so all layers A through E are sedimentary because they formed in flat layers. Sometimes magma will melt through the sedimentary layers and form what's called an igneous intrusion. And if that layer is also cutting across the fault, then the fault, we'll call that layer Y, the igneous intrusion. So Y would be younger than X and also younger than all the other layers that it's cutting across. If the fault came after the intrusion, then the intrusion would also be broken and not lined up with itself across the fault. So that's the law of cross-cutting. We also have something called the law of inclusions. So U, the law of inclusions. And in the law of inclusions, we'll just take a section of sedimentary rocks and we'll say we'll have 3 layers. One of them will be cross-hatched like this. One of them will be just white. And the other one will be little dots. And then we're going to have an igneous layer cutting across part of it. And that igneous layer is going to be colored in like this, but it contains fragments of the other 3 layers. And so when a layer contains fragments of another layer, the fragments have to be older than the intrusion in this case. So you could tell that the igneous intrusion is newer in this particular case based upon the law of cross-cutting and the law of inclusions, because it contains part of the cross-hatch layer, part of the white layer, and then part of the dotted layer. So the law of inclusion say if a layer contains fragments of another layer, then the fragments are older. And then the last one that we're going to draw is something called an unconformity. So what an unconformity means is you have sedimentary layers that are mostly perfectly flat with one another, having formed as sedimentary rocks. And we'll do some different patterns on the layers. But then there'll be one border that's all jagged. And then sometimes there'll be more perfect layers on top of the jagged layer. And so sedimentary rocks, like we've talked about, always form at the bottom of a body of water. What this one kind of jagged layer means is that at some point the body of water might have dried up. And so there was a period of erosion. So an unconformity is going to be a jagged layer that shows a period of erosion. So you can say like this layer is older than that layer, is older than this layer, is older than this layer, is older than the unconformity, and then after the unconformity, this layer formed, then this layer formed. What you don't know is if like there may have been another layer that completely disappeared through the process of erosion. But that's how unconformities work. So layers A, B, C, and D were deposited before the unconformity, before the period of erosion, and layer E and F were deposited afterwards. All right, that's going to be it for now.